So hello and welcome to new DevOps video series. So in this video series, we'll be taking a look on how Helm and Argo CD can be used for our continuous deployment or delivery. So let us first get started with the application architecture. So here we can see this will be our architecture that we'll be following. So the above section includes our continuous integration and the below section includes the continuous deployment. So today in this demo series, we'll be implementing the continuous deployment part. So for this we'll be using Helm and Argo CD, and for our source code repository we'll be using GitHub, where our code or the Helm charts will be located. So let's start with what Helm is. So Helm is a Kubernetes package manager that simplifies the deployment and management of applications on a Kubernetes cluster. It achieves this by packaging Kubernetes resources into a chart, which is essentially a pre-configured set of templates and values. So Helm basically includes of three components that are chart, template and values. So this chart can be versioned and shared, and with the help of which it provides a consistent and a repeatable way of deploying our application. So in this project we'll be utilizing Helm to encapsulate and organize our Kubernetes manifest file, allowing us to define the structure of our application, set configuration parameters and manage dependencies. So storing our Helm charts on GitHub makes them easily accessible and version controlled. So whenever we want to deploy or upgrade our application, Helm makes it straightforward to do so with a single command, ensuring consistency across different environments. So here we can see the configuration and Kubernetes manifest file are located on GitHub. And we'll also be using Argo CD. So talking about Argo CD, it's a GitOps approach to continuous delivery for Kubernetes. So it synchronizes the desired state of our application as a declared in the Git repository with the actual state in our EKS cluster. This ensures that the configuration and versioning of our application are managed through Git, providing a robust and auditable deployment process. So in our scenario here we can see Argo CD connects with our GitHub repository and continuously monitors for the changes in the declarative state of our application. So whenever there are any changes that are detected, so Argo CD automatically triggers the necessary action to bring the EKS cluster into the desired state. So this declarative approach simplifies the deployment process, enhances version control and facilitates collaboration among team members. So together using Helm and Argo CD, we can create a powerful combination for managing the lifecycle of our Kubernetes application. So Helm organizes and packages our application, while Argo CD ensures that our applications are deployed and maintained according to the version and auditable configurations stored in our Git repository. So this approach enhances reliability, traceability, and collaboration in our Kubernetes environment. So yes, this is the general architecture that we'll be following. So without further ado, let's get started with our demo. So please follow along this video until the end so that you will be having a great understanding regarding what Helm is, what Argo CD is, and how things work using Helm and Argo CD. So yes, let's get started. So as you can see, I am currently logged into my AWS EKS platform. So here we can see I'll be creating my AWS EKS cluster. So before that, let me also show you my instruction or the installation steps that I'll be following while completing this project. So first of all, we'll be creating an EKS cluster. So follow AWS documentation or use AWS Management Console to create an Amazon EKS service or the cluster. Ensure that the cluster is up and running. So let me first move on to my EKS cluster, and I'll be adding a cluster here. So I'll be creating a cluster. So this will be my Argo Helm cluster. So my Kubernetes version will be 1.28 and I have selected a cluster service role, that is my AWS EKS cluster role. So let me show you the role, and I'll also be showing the policies which are attached with this role. So let me copy this role, my AWS EKS cluster role. So my AWS EKS cluster role. So this is the role that is attached with this cluster, and here we can see it has the policies. So the policies includes Amazon EKS cluster policies. So cluster policies includes all the services policies that are required by our cluster. So secret encryption, I'll be turning it off itself. So let me go to next, and I have selected a VPC 0924, which is also the default VPC, and I have also selected 3 subnets. These are the subnets that are associated with this VPC. And for the security group, I have left it as it is so that it will be creating a new security group, or I can also select any of the security group. So the cluster endpoint access is set to public so that our cluster will be accessible from outside of our VPC, and worker node or traffic will leave your VPC to connect to the endpoint. So in the basis that will be done, and I have choose the cluster IP address family to IPv4. So let me do next. And about observability, if you see, we have multiple logging options that we can enable, but for now I'll be setting it off because we will not be requiring, because it will be a quick demo project. So let me select next, and for the add-on I'll be adding 3 add-ons that are kube proxy for our service networking, and core DNS for our service discovery, and VPC CNI for our pod networking within our cluster. So let me select next, and I have selected the version of kube proxy to version 1.28.1. For core DNS I have selected 1.10.1, and for VPC CNI I have selected 1.14.1. so let me select this to next. So this is the name of my cluster, Argo Helm cluster. This is the Kubernetes version, and so on. So everything as it is, I'll be creating this. So as we are also already familiar that the creation of the cluster will be taking around 15 to 20 minutes. So let's wait until then. Let us go to the EC2 section and let us create an EC2 instance. Using this EC2 instance, we'll be connecting with our cluster. So this will be my control plane. So since we are using this to interact with our control plane, so I have giving it a meaningful name with the control plane name. And so I'll be selecting T2 micro instead of micro. I'll be selecting T2 medium with 2.4. And for firewall, I'll be creating a new security group where I'll be allowing SSH traffic port 22 and configure storage. So I'll be creating a storage with 20 GB. So let me launch the instance. Okay, so I have not selected the key pair, so I'll be selecting the key pair here, and let me launch the instance. Okay, so the instance is on pending state, so let's wait until the instance will get on the running state. Okay, so the instance is on running state, so let me connect to this instance. Okay, first of all, what we did is we created an AWS EKS cluster through AWS Management Console, and we are also trying to configure the cluster setting including the VPC, and we also need to create a node group and worker node but for creating that our cluster need to be in running state, so let's wait until that's done. So then we created an EC2 instance to connect to our cluster, and I gave the EC2 instance name with control plane, and let us ensure that our instance has necessary permission to interact with the EKS cluster. So for interacting with our cluster, we'll be first requiring kubectl to be installed on our instance. So let me clear the screen once and let me show you. So first of all, we'll do SSH into the EC2 instance, and I'll be downloading the kubectl. So for that, let me copy this and let me paste this here. So it will be downloading the kubectl binary suitable for Linux, and it will be making the binary executable with chmod, and it will be copying the kubectl to the system's binary directory, that is user local bin, to make it globally accessible, and it will be updating the system path variable to include the directory where the kubectl is located. So whenever we are trying to interact using the kubectl, it will be available. So let me do kubectl and let us check if it is recognizing or not. So here we can see it's recognizing kubectl. So let me also check kubectl version. Okay, so the was refused. Okay, client version info measure, we will see git commit build and customized version, it is 4.5.4. so we are good to go. Then what do we need to do is, let's go here back to this, and we'll also be installing AWS CLI, because we need to configure our EKS cluster with this kubectl here. Okay, so we are downloading the AWS CLI installation package for Linux, and we are unzipping the package and installing the AWS CLI with sudo command. So here we can see sudo apt install unzip. So in the second step we were trying to unzip, but because the unzip package is not present with us, so it's giving us that unzip cannot be installed. So let me first install unzip. Okay, let me first update the system once. Okay, let me log into as a root user and apt update. Okay, so let's see if our cluster is on running state. So it's still on creating state, so nothing to worry about. So our package has been also updated. So apt install unzip will be installing the unzip package. Okay. Okay, let me clear this and let me rerun the AWS CLI installation command once again. Okay, looks like I was running that from Ubuntu user, and currently I am logged in or interacting with the root user, so that won't be available. So let me again once copy this, and let me again download the AWS CLI installation package for Linux and unzip it. So this might also take some time. After that we'll be setting our Kubernetes context, but before that I need to configure my AWS for this instance. So for that I'll be requiring my access key and secret key. So for that I have already copied or downloaded my access key and secret key from my AWS. So these are my access key and secret key. So after the successfully completion of video, I'll be deleting these keys, so this won't be working at your end. And exposing these kinds of access key and secret key publicly is a huge risk, because anyone who will be having access to the access keys and secret key will be able to access our AWS account and will be able to create any kind of services that are associated with this access key and secret key. So please be careful or mindful while you are interacting with such kind of access keys and secret keys. Okay, this might take some time. Let me go back to my EKS. Let me refresh this. So it's still on creating state, so this might take some time. So here we can see it was created 7 minutes ago, but still it's taking some time. Okay, let me do a hard reload once. Sometime what it happens is it doesn't reflect, so it's still on the creating state, so no issues. So let me go back to my instance, and we have successfully unzipped the CLI, AWS CLI. So let me do AWS configure here. Okay, let me first clear the screen and then AWS configure. So it's asking for access key. I'll be providing the access key that I have here. And also my secret key. So this is my secret key. Paste. And the reason is, as you can see, I am interacting with Ohio region, which is here itself, so it will be my US East 2. So we can't give the region name as Ohio, we need to give this ID that is associated with the specific zone. And output format I'll be leaving as it is, and let me clear this. So we are good to go. Now we need to set our EKS context here, but before that we need to have our cluster running. So here we can see our cluster is active and running. So let me go back here and let me run this command. So here what I'm trying to do is, as you can see here, we are trying to configure kubectl with the credential and cluster information so that it will be able to interact with our EKS cluster that we just created. So before that we need to provide the region. So my region is US East 2. This is the region where our EKS cluster is created, and the name of the EKS cluster is Argo Helm cluster. So that will be my ARGOHELM and CLUSTER. So this is the name of my EKS cluster and the region as well. Okay, so here we can see added new context, so we are good to go. So kubectl get nodes. So here we can see no resources found. So this is because we haven't yet created nodes in our EKS cluster or within our EKS cluster. So for that, let me go to cluster section once and let me go to compute section, and here we can see there is no node group. So let me add this node group. So this will be my node group, and I'll be selecting IAM role. So that will be my Amazon EKS node role. So let me show you this as well. So within role, node role. So this is the node role. So here we can see it's provided with certain permission. So this EBS CSI driver policy we do not need, but last time when I did a project over the AWS EKS console, so we did deployment of a stateful application. So based on that, I have this policy attached. Then other than that, we'll also be requiring EC2 container registry read permission and EKS CNI for our networking and worker node policy as well. So you can add all of these policies and create a role, and you can attach this role to the node group. Okay, so let me select the role. So that's the same role that I have created, and other things I'll be setting this as it is, and AMI type will be Linux, and capacity will be on demand, and I'll be selecting T3 medium to BSPU 4GB RAM. This will be costing a charge. So if you're trying to complete this project within 1 or 2 hours, that will be a minimal charge, but it's gonna get you charged. But if you leave it for a day around 2, so you'll be getting higher charge. So if you're trying to follow with this video, please keep that in mind that it's going to charge you, and the charge will be very high if you leave it or if you don't destroy after completing this project. So the desired size, I'll be setting this to 2 nodes. Minimum also set to 2, and maximum will also be set to 2. Let me go to next, and I've selected the 3 subnets within my VPC, and let me do review and create. So this will be creating my node. So we'll be having a EKS cluster where we'll be having 2 nodes of T2 medium. Okay, so the status is creating. So let me go back to my steps. So now what we'll be doing is we'll be installing Helm. So as I mentioned, talking about Helm, so it's a package manager for Kubernetes that simplifies the process of defining, installing and upgrading application in a Kubernetes cluster. It uses charts, which are pre-configured templates that define how to deploy application and their dependencies. The key feature of Helm is it enables versioning, templating and sharing of Kubernetes manifests, making it easier to manage, and we can manage a huge complex application using Helm. So these are the kind of key features that are provided by Helm. So let me go here and let me run this. So it will be downloading the Helm script, and we need to provide permission to that script, and we'll be executing the script itself. So for that, let me go to the EC2 instance again. Let me paste this here. Okay, so let me copy this and let me paste this here. Looks like that's not copied, so let me do ls. Here we can see there is a get helm, so chmod plus x. Okay, so let me first do ls -la, and let's say get helm.sh. so it has read write and read only, so we are trying to get it executed. So for that, let me add the same here. So chmod, that will be done by itself. So let me copy this command so that anyone following with this script will be ready. And so we could see it's installed and installed on the location as well. So let me do Helm. So here we can see the Helm is installed and is working fine. So Helm search, Helm push, Helm list. So Helm search will be searching the charts. Helm pull will be downloading the chart from our local directory to view. Helm install will be uploading the chart to Kubernetes, and Helm list will be listing the releases of chart. So we are good to go. So let's check the Helm version. HELM BERSIO, and will be giving us the version. So here we can see it's version 3.13.1. Okay, so let us first create a Argo CD, and as I said, we'll be using. So let me first go and create a namespace Argo CD. So as I specified or said during the last time, so namespace is like a cluster within a cluster. So we are creating a namespace with Argo CD. So namespace are used to organize and isolate resource within the cluster. So we'll be checking the list of Helm repositories with the command Helm repo list. Okay, so here we can see there are no repositories to show as of now. So we'll be adding a repo here. So that will be the repo for Argo CD. Okay, let me paste this here and let me run repo list once again. So here we can see it's been added, and we'll be installing Argo CD using Helm. So let me copy this. Okay, so we are using Helm to install Argo CD with command Helm install Argo CD and argo/argo-cd, and the namespace is Argo CD. So this will be deploying Argo CD in the Argo CD namespace. So this is the namespace that we just created. So it will be installing Argo CD within that namespace. So let me hit enter. So this might take some time. Okay, so name Argo CD and so on. So now we'll be able to access our Argo CD from the browser, but for that we need to make our Argo CD UI accessible. So for that we need to change the service type. Okay, so let me go back here and we'll see over here itself. So first let me get the password so that it will be accessible from the browser, and let me clear this and let me do ls. So here we can see. Okay, so let's see kubectl get ports -n and Argo CD. So here we can see there are multiple ports associated with Argo CD that are currently running state. And let me retrieve the Argo CD admin password first. Copy, paste. Okay, so this is my Argo CD password. So let me copy this and I'll be pasting this somewhere below here. Is equivalent to this. Okay. So currently we won't be able to interact with our Argo CD UI. So for that, let me change the service type. So for that, what I need to do is I need to go to my Argo CD service and I need to edit the service. So let me copy this here. Okay, let me paste this. So it will be editing the Argo CD. So you can see it's a kind service. So meta helm.sh release name is Argo CD and the release namespace is also Argo CD. So creation timestamp we will see it's the current date, and the labels we could see is set accordingly. So the name is Argo CD server and the namespace is Argo CD. So the cluster IP is 10.100.8.159. Cluster IPs is also same. Okay, so these are the default things, so I won't be describing much about this, but what we need to do is we need to change this cluster IP type to load balancer. So let me go to the type and let me change my cluster IP to LOADBALANCER. Okay, so it has been edited. So let me set alias k equals to kubectl so that it will be easy. So k get SBC, our namespace Argo CD. Okay, so here we can see our Argo CD server. So the cluster type is the cluster IP type is changed to load balancer, and this is the external IP. So I'll be copying this and I'll be pasting this here, and let me hit enter. Okay, so this might take some time. Okay, so here we can see our application is ready. So let me put the username as admin, and I have copied the password there as well. So let me copy the password from here. Okay, let me go back here and let me paste the password here, and let me do a quick sign in. And before that, let me go to my AWS once, and here you can see there is a EC2 section, and within EC2 section there is a load balancers option or the service. So here we can see there is a load balancer created. So let us see when this was created. So November 9, I think this is the current date and time that's been created. Okay, so we are good to go. So we are also able to access the Argo CD as well. So now I'll be creating a new app, but before that, so yes, let me create a new app, and my application name will be, so since we are trying to deploy our Nginx image, or Nginx deployment is what we are trying to do, so I'll be creating a Nginx image and I'll be deploying that. So for that, my application will be app nginx. Project name I'll set it to default, or it will be my nginx app. Okay, so the syncs policy will be automatic. So prune resources, here we can see if checked, Argo will delete resources if they are not longer defined in Git. So we do the sync, and based on the sync, things will be working. And if you see, if we do prune resource, so if it's synced with the Git, and if there are no resources longer available on Git, it will be deleting the resources and so on. So you can check this by yourself, so I won't be describing this much. So I'll be creating a separate video for Argo CD and Helm as well. Okay, so other things as it is, print propagation policy, I'll be setting it to foreground itself, and I do need to provide a repository URL. So for now I am using this repo that is provided by Helm itself. So okay, let me copy this and I'll be pasting this here. So the revision, I'll be selecting this to my head itself, and the parts will be my charts/hello world. So if I go here and if we check the repo here itself, I'll be showing that, and the destination cluster will be Kubernetes destination server service itself, and the namespace. So for that I need to create a namespace within my cluster. So let me clear this and kubectl. Okay, I have set my alias to k get, or get ns will be giving my namespaces. So here we can see I have Argo CD, that was the namespace created for Argo CD, but I do need to create for my application. So kubectl create ns and or -n, and this will be my nginx ns namespace app namespace. So namespace app namespace created. So let me clear this and let me go back here. or let me do k get ns. Okay, so app ns is created, app namespace is created, so this will be my app ns, and Helm values will be taking this from values.yml. So if you are wondering why I have provided this charts slash hello world, so this path is what that I just provided, so it will be checking the path or the charts from this chart slash hello.world, and here we can see there are multiple templates for deployment, for service account, and there is values.yml. So our values are stored over the values.yml. So the type is set to cluster port is set to 80, and we have a service account which is create type is set to true, and we have the repository name or the image, that is nginx, and we have set the pull policy as well, that is if not present it will be overriding the image whose default is the chart app version, and so on. So the things are as it is, and the values will be values.yml, and image pull policy will be if not present, which we just showed here. So based on this if not present, and the repository name nginx, it's pulling this on the basis of that, and replica count is set to n, and the service type is set to cluster IP as of now. So I'll be changing this cluster IP to load balancer, and we'll be accessing our application over the load balancer. So for now I'll be creating this application. Okay, it's syncing. Here we can see the status, it's progressing. Let's see. So the status is healthy, so our deployment is done successfully. So here we can see sync status is set to synced with the head with the commit ID, that is 4888BA8, and this was the last sync, and so on, and other thing as it is. So here we can see the author and the comment, and auto sync is also enabled, and yeah, things are working fine. So now let me do one thing. So app details, under app details I'll be going to the parameter, and I'll be editing the parameter here. So what I'll be editing is sorry, I think I missed, okay, parameter, and within the parameter, okay, let me go to the manifest file itself, let me go to the parameter and let me edit, and what I'll be editing is I'll be editing the class service type, that will be my load VALANCER. So let me save this, and here currently we are seeing only single load balancer. So now after some time we'll be having two load balancer, as we can see here. So the next load balancer is added, and let me go and check the load balancer here. So for this, let me create this, and so for this service, so this is the host name for this. So DNS propagation might take some time, so let me copy this and let me paste this here. Okay, so this might take some time because DNS propagation takes some time. So yes, we are good to go. Now I'll also be changing one or two things here. So as of now we could see there is a single pod running for this nginx application. So it's a simple way out how things can be simplified here. So if let me show you, let me go to the app details once again, and let me go to the parameter, and what I'll be changing is I'll be changing the replica count. So I'll be changing the replica count to 15, let's say. So let me save this, and boom, here we can see we have 15 pods, which are some of which are already on healthy state, and some of them are getting created. So this won't be taking a much time, and everything will be working as it is. So based on this replica set, so we have a deployment file where we are defining our replica set as 15, and based on this replica set, that is 15, so it's creating a 15 pods and maintaining the amount, that is desired amount and the actual amount. So that is our desired replica count needs to be 15, and it's making the actual size to 15 itself. So in this way we can benefit using Argo CD. So these are the kind of things that we can do from here. So let me once refresh this once again. Okay, so here we can see welcome to nginx. So as I said, this is a simple deployment that we are trying to do using Helm, Argo CD, and GitHub. So this I have taken from the Helm repo itself. So yes, this will be it for this video, and I'll be bringing a next video or a newer video where we'll be discussing more regarding its benefits and feature and how powerful it is. So yes, thank you for watching, thank you for your time. And so in this way it works, and also I'll be showing you one or two other things from here. So here we can see, as I said, we are trying to deploy it on our EKS cluster, and within our EKS cluster there are two nodes. So these are the two nodes, and as we set our replica count to 15, so here we can see we have 1 2 3 4 5 6 7 8 and 9 10 11 12 13 14 15. So our 15 pods are okay and running. We do not need to worry where our deployment or the workload will be deployed. So any of the node will be working fine. And here we can see the distribution is in the basis of this. So here we can see the capacity, CPU capacity is 150 M, and the overall capacity is 200 M, and here we can see 350 for neighbors and 2000 M for the capacity, so on. Yes, so in this way we can interact, or we can have our visual understanding regarding our cluster and so on. Also we can see the view from this way as well. So from the internet, using service, it is trying to interact with our application, and the service is then routing it on any one of the pod. So in this way the application architecture works, and in this way the application is interacting. So yes, thank you.